what's the cost of saving a life, basically? Like how much money would you have to spend to reduce the risk by, one person in a million, something like that. Okay, so this is just that note that MCLGs for carcinogens are as low as technically feasible. By the way, I forgot on the first slide to point out, thanks to Bruce Thompson for advice, and I almost punted on this whole thing and said, Bruce, why don't you give this talk? Because he gives a really nice talk that's kind of related as well. So I plagiarized a few of his slides, such as this one. So this health risk analysis, how do you get to the number that you're shooting for? So you need to know something about the dose and the response. Okay? So that response could be mortality, it could be getting sick, it could be skin lesions, right? And for any contaminant, or for any chemical, there's going to be this shape of a dose and a response. Okay? And this is the no observed adverse effect level, okay, down here. So it's the level at which you think that, if I'm below this concentration, I'll never see an effect in anybody. Right? So that's what the MCLG is based on, is that that no observable adverse effect level. So at the end of the day, a panel of experts, this is not, an objective thing, that because often when you have data out in here, but it's hard to get data down toward your target because you're trying to measure very small amounts of risk, right? So you're necessarily extrapolating, right? So you have to get a panel of experts to kind of agree on what's the reasonable extrapolation, and sometimes they're arguing about, should this model be a linear fit, should it be some polynomial fit, which is often hard to do because you're pulling data from different studies, right? So arsenic is a great example of that, which we'll talk about more in just a second. Okay, so the acceptable risk, which is established in the regulations, is in the range of 10 to the minus 5 to 10 to the minus 6 deaths over a 70-year lifespan. Okay, so it's not per year, it's in a 70-year life. Okay, so this is be about 1 in a million, right? So in Albuquerque, that would translate to 1 to 10 excess deaths in 70 years. Okay, this is kind of an ethics question. Is that a reasonable level or not? But you have to set it at something.
That is about 1 order of magnitude more tolerant than an airline.
That's interesting.
Any idea why that is? Well, I expected it to be 10 to the minus 7th is what I expected that number.
Really? Yeah. And I had.
It's about a half 10 to the minus 7th.
I don't know why that is. I don't know. It often comes down to, as I said, costs, right? So it's probably it's a little bit easier for the airlines to control, right? As I said, there's so much extra. Well, and then there's another element here, which I don't know if I actually put in the formula. This may include, basically at this point, I don't think I put in the actual formula. Oh, I just didn't mention it. So yes, right. So you argue about what should this no observed adverse effect level be, right? And then there's uncertainty there, so then you include a safety factor, right? And that safety factor can be anywhere from 10 to 1,000, right? So there's another built-in, so that gets you to maybe the airline risk if you just do it objectively mathematically.
It would be based on how much you really know about the problem.
Right, which in the case of an airline, I guess you do know a little bit more.
You know an awful lot.
You got a lot, if somebody dies in an airline crash, you know about it, right? And with drinking water, it's much more difficult to know. Right?
You also know why on the airplane. And
right.
Water, you may not have as good
a
measure of why.
Right. So yeah, I think that's the answer then. Is that there's more uncertainty here, so we incorporate part of that into a safety factor, right? So that I believe that 10 to the minus 5 or 10 to the minus 6 does not account for that as safety factor, right? So that's kind of an added aspect of safety there. Okay. So sometimes these risk determinations are not very simple. Consider arsenic. Okay, this is just an example of what they're up against. So arsenic is associated with a lot of different problems, skin lesions and whatnot, and also several cancers. Okay, the best correlations to are to bladder cancers in elderly men. Okay, so that happens. So it's more significant for men. And you know, Bruce Thompson, you know, and increasingly myself, being older guys, you know, he always likes to make the point. It's like, is this appropriate? You're making all society pay for this risk to old guys, right? Right. So you know, when he presents this data, he really makes the argument that like the arsenic level probably should not have been decreased. Right.
But hey, some guys appreciate it.
That's right. You know, I appreciate the thought. So, and this is kind of a key point here is that in 2001, this, I don't know if you remember, this was a big controversial thing. Been argued about for over 10 years, whether they should decrease the MCL from 50 parts per billion to 10 parts per billion. And finally, in 2001, they finally did it. And it's a significant upgrade. It's a significant thing that plants have to do to get out that extra. So we're talking parts per billion here, really, really small numbers, right? So it meant that a lot of plants had to put in significant added levels of arsenic removal. And this is kind of what that was based on. And the other note here is that prior to, like, this was written in 1999, there wasn't much data at all on anything over a few hundred micrograms per liter. Okay? And you could try to do this in like animal studies and whatnot, mice and whatnot. That gives you one set of data. But your best stuff is going to be epidemiological studies. And one of those came from a population in Taiwan where there were some wells that were contaminated, some that weren't. There was also a lot of data that comes out of India where arsenic contamination, actually well-intentioned. They drilled a whole bunch of wells. I think the World Health Organization helped sponsored a lot of wells, and it discovered after the fact that the groundwater was contaminated and actually causing a lot of public health problems. So yeah, it was tragic, but it did provide a lot of data about arsenic health effects. So this came out of Taiwan, and this is, well, some of this did, the triangles came out of Taiwan, and you can see the scatter in the data, right? Well, here's actually, I guess all the data is out of Taiwan. I think this was just part of the Southwest Taiwanese population. But you can see the scatter in that data. So now the experts are arguing, should we use this model? Should we use that model? Should we use a linear model, right, to extrapolate down to where you want to be with the lifetime risk that you're aiming for. And here's the 10 micrograms per liter standard versus 50, right? So huge error bars in that discussion, right? And that was one reason why it was so controversial.
It sounds like it's more a political discussion than it is a factual,
it definitely
mathematical.
Yeah, it's, even that statement's controversial. So it's like, yeah, and it did get very political. There's no doubt about it. It got very political.
And there's so many variables to determine what is associated with the cause.
Right. Right. Yeah. So it was done, and again, a lot of this came from Bruce, who has a perspective on it. There have been no studies in the U.S. that showed that there's a problem with greater than 50 micrograms per liter. Then these epidemiological studies are highly variable, and the extrapolation is difficult. And the issue is really, just the raw data. In addition to this extrapolation thing, trying to figure out what somebody's lifetime exposure really is. It's not like you have one person drinking from the same well for 70 years, right? So you're, right off the bat, you're making some assumptions, probably very conservative assumptions, right? And did they die from that? They got bladder cancer. Maybe they got arsenic exposure another way. Maybe it was just naturally occurring. It's hard to tell. So in Albuquerque, this was important for Albuquerque because so this is from an old water quality report from Albuquerque from, I think this is the 2007 report. And shown here, obviously, is a map of Albuquerque. And these are the wells around town. You see these around town with big storage tanks, right? So every one of those is associated with a well. And these are the arsenic concentrations in blue 2003 and in black 2007. And you can see that many of these are higher than that 10 ppb standard. So they were fine before, but with the